गुड मॉर्निंग बच्चों। आज हम रेट लॉ एंड ऑर्डर ऑफ रिएक्शन डिस्कस करेंगे और कुछ पास्ट पीवाईक्यूज डिस्कस करेंगे जो जेई मेन एग्जाम में आए हैं। सो लास्ट सेशन में हमने डिस्कस किया था रेट ऑफ ए रिएक्शन। सपोज एक रिएक्शन दी है ए प्लस बी बी इक्वल टू सी सी प्लस डी डी, तो इसका रेट ऑफ रिएक्शन इज रिटन एज like this. So minus 1 upon a dA by dt equal to minus 1 upon b dv by dt equal to 1 upon c dc by dt equal to 1 upon d dd by dt. एक्चुअली ये जो रेट है ये बेसिकली दिखाता है द रिलेशन बिटवीन रेट ऑफ डिसअपीयरेंस ऑफ रिएक्टेंट्स एंड से रेट ऑफ अपीयरेंस ऑफ प्रोडक्ट से dc by dt. Okay, so we can say that rate of disappearance of A is equal to small a by small c times rate of appearance of C. So basically ये दिखाता है हमें how the rate of disappearance of reactants are related with the rate of appearance of products. आज हम जो डिस्कस करेंगे that will be the dependence of rate on concentration of रिएक्टेंट्स. ओके, तो अगर हम इस रिएक्शन का रेट इन टर्म्स ऑफ कंसंट्रेशन ऑफ रिएक्टेंट्स लिखें, सो रेट विल बी प्रोपोर्शनल टू से कंसंट्रेशन ऑफ ए टू द पावर एक्स, कंसंट्रेशन ऑफ बी टू द पावर वाई. जो एक्स एंड वाई हैं दे आर डिटरमिन्ड एक्सपेरिमेंटली. ओके, एक्स मे बी इक्वल टू ए और मे नॉट बी इक्वल टू ए. सिमिलरली वाई मे बी इक्वल टू बी और may not be equal to b. अगर x equal to a हो और y equal to b हो, then we say that this is elementary reaction. Elementary reaction वो reactions होती हैं जिनमें order is equal to molecularity. In that case, we can equate the order with the stoichiometric coefficient. But in general, this x and y they are determined experimentally even for the elementary reactions. So we can say that this x and y they are called order of the reaction. So we can say that this reaction is having order x with respect to reactant A and order y with respect to B, and the overall order of the reaction say n is equal to x plus y. Okay, so this is the order of reaction which is determined experimentally. Okay, now if I want to remove this proportionality constant, then I can write rate equal to k into a to the power x b to the power y. Okay, so how we define this k which is called rate constant? So we can say that rate constant k is equal to rate, okay, when concentration of all reactants are unity. So if concentration of A is 1, concentration of B is 1, then K will be equal to rate. So that is the definition of rate constant. Now suppose I write this equation as rate equal to K into say concentration to the power n. Then n is called the overall rate of the reaction. Okay. So what will be the unit of K? Unit of K will be unit of R, that is moles per liter second inverse divided by moles per liter की power n, that will be moles per liter to the power 1 minus n into second inverse. So that is the unit of K. Okay, suppose I want to write the units of K for zero order reaction. So this is a zero order reaction. then what will be the unit of K? That will be nothing but moles per liter into second inverse. That is the same as the unit of rate. Okay, we put n equal to 0. It will become moles per liter second inverse. For first order reaction, unit of K will be second inverse, and for second order reaction, what will be the unit of K? That will be liter per mole into second inverse. So that is how we can find the units of K. Sometimes you are given that the question is given that for a given reaction the rate constant K is say 5.8 liter per mole second inverse. What is the order of this reaction? So if you know the units of K, you can straight away say that this is a second order reaction by seeing the unit of K. Okay. Now we take some past year questions. 3 past year questions we will take. Then we will wind up this session. This first question is, it was asked in 2019 main. It says that for a series reaction, A gives B and B gives C, and here the rate constant is K1, here it is K2. Okay, so these are the series reactions. And it is said that the rate of formation of B is set to be 0. Means rate of formation of B, that is the net rate of formation of B, is said to be 0. What we have to find out is the concentration of B is given by, 4 options are given to us. The concentration of B is given by, the 4 options are K1 plus K2 into concentration of A, then K1 by K2 into concentration of A, then C, K1 K2 into A, and D option is K1 minus K2 into concentration of A. So how we will do it? This is a series reaction, so B is formed by this reaction and B is getting disappeared by this reaction. So we can, for the first reaction I can say minus dA upon dt equal to K1 into A is equal to dB by dt. And for the second reaction I can say minus dB by dt is equal to K2 into B. Okay. Now we can say that जो B है वो फर्स्ट रिएक्शन की वजह से बन रहा है और सेकंड रिएक्शन की वजह से डिसअपियर हो रहा है. सो नेट रेट ऑफ फॉर्मेशन ऑफ B will be nothing but rate of formation of B due to first reaction, that is K1A, okay, minus rate of disappearance of B due to second reaction, which is K2 into B. Okay, so this is the net rate of formation of B, net rate of formation of B. Now it is said to be 0, it is given, so this is equal to 0. Then we can say that K1A is equal to K2B. What we have to find out is the concentration of B. So concentration of B will be equal to K1 upon K2 into concentration of A. So B option is correct. So that is how we can solve this type of numericals based on rate law. Now we take one other numerical where log of rate versus log of concentration of reactants. This graph is given to us for four different reactions, that is A gives product P1, B gives product P2, C gives product P3 and D gives product P4. Okay, and what we have to find out is the order of these reactions. So these four graphs are given to us. This is graph number say 1, this is second graph, this is third and this is fourth graph. Okay, so we are given the four graphs here. One is like this. Okay, and we have to arrange them in their order of reaction. So these are the four reactions. Okay, whose we have to tabulate the increasing order of order of the reaction. So how we will do? We know that rate of reaction can be written as K into concentration to the power N, where N is the overall order of reactions. If we take log of both sides, we get log of rate equal to log of K plus N log concentration. So this is like y equal to mx plus c, where m is the order of reaction, that is the slope of this curve will be the order of the reaction. Okay, so whichever is having higher order, having the reaction having higher slope will have higher order. So that is how we can find out the increasing order of the order of reaction. Higher will be the slope of this graph, higher will be the order of the reaction. Now we take one more question, then we will wind up this session. This question is, this was asked in 2019 May. Here for the reaction 2A plus B gives C, the values of initial rates at different initial concentrations are tabulated. So a table is given to us where we are given the concentration of A in moles per liter, that is initial concentration, and concentration of B, that is also in moles per liter, and initial rate of reaction is given. Initial rate of reaction, its unit will be moles per liter second inverse. Okay, so these values are given to us. 3 experiments were done and the values are tabulated here, that are given in our numerical. So this is 0.05, then 0.05, and the rate is 0.045. Concentration is 0.10, and this is 0.05, and this is 0.090. Then it is 0.20, and this is 0.10, and this is 0.72. Okay, and we have to find the rate law for this reaction. Rate law for this reaction, the four options are given to us. A, rate equal to K, concentration of A square, concentration of B square. Then B option is rate equal to K, concentration of A into concentration of B. And C is rate equal to K, concentration of A into B square, and the D option is rate equal to K A square into B. So this type of numerical, what we will do, we will just observe and then we can find out the rate law. How we will observe? हम पहले ऐसा लेंगे जिसमें दोनों की दो कंसंट्रेशन सेम हो. ओके, यहाँ पे हम देख रहे हैं कि B की कंसंट्रेशन सेम है. सो एट सेम कंसंट्रेशन, दैट इज कांस्टेंट concentration of B, if I increase the concentration of A from 0.05 to 0.1, यानी concentration of A अगर डबल करता हूँ तो रेट भी डबल हो रहा है. इसका मतलब with respect to A, your rate is proportional to A to the power 1, because जब इसका हम concentration डबल करते हैं तो रेट भी डबल हो जाता है. इसका मतलब रेट इज proportional to concentration of A, because B is constant. सेकेंड केस में हम ये देखेंगे कि हाउ दिस रेट इज अफेक्टेड बाय कंसंट्रेशन ऑफ बी. ओके, अभी हम यहाँ पे देखते हैं जब हम कंसंट्रेशन ऑफ ए डबल करते हैं, ओके, तो इसकी सेम है. अब यहाँ से यहाँ जा रहे हैं, मान लो हम इसकी कंसंट्रेशन 0.05 से 0.1 हुई, यानी कंसंट्रेशन ऑफ बी इज डबल्ड. ओके, एंड कंसंट्रेशन ऑफ ए इज आल्सो डबल्ड. हमें पता है कि कंसंट्रेशन ऑफ ए डबल करने से रेट डबल हो जाएगा, यानी रेट कितना हो जाएगा, 0.18 हो जाएगा. इट इज ड्यू टू ए. ओके, रेट विल बिकम डबल, दैट इज 0.09 into 2, दैट इज 0.18. और बी की भी डबल हो रही है, तो बी की डबल होने से ये 0.8 से 0.72 हुआ. दैट इज ड्यू टू बी ओनली. ओके, बिकॉज ए के डबल होने से रेट डबल हो गया, दैट इज 0.09 से 0.18 हो गया. ओके, अब बी की डबल की हमने तो रेट कितना हो गया, 0.18 से 0.72, दैट इज ड्यू टू बी, मीन्स 4 टाइम्स हो गया. यानी व्हेन कंसंट्रेशन ऑफ बी इज डबल्ड, रेट हैज बिकम 4 टाइम्स. सो वी कैन से दैट रेट इज प्रोपोर्शनल टू कंसंट्रेशन ऑफ बी टू द पावर 2. ओके, सो द रेट लॉ विल बिकम this. This is the rate law. So which option is correct? We can say that C option is correct. So that is how we can solve this type of numerical, where these initial rates of reaction are given with respect to initial concentration of reactants, and we are required to find the rate law. With this, I conclude the session and wish you all the best. Thank you.